Okay, so in this video, we are going to practice finding the domain if we're given equations. So there's three different types of equations we're focusing on at this point of this class. So if we take a look at example 7, we have a fraction. So what we know about fractions is that the denominator of the fraction can never equal 0. So we want to find out what number, if we put it in right here, will make this 0. So we're going to solve. Instead of guessing, we'll solve to figure out that number. And when we get the x by itself, we find out that x cannot be 4. So again, let's make sure it's crystal clear why x cannot be 4. So if I plug in 4 for x, we get 7 on the top, which is completely okay. But here in the denominator, we would get 0, which is not okay. So if we put this in our calculator, 7 divided by 0, we have an issue, right? So it could be any number but not 4. So if I draw a picture of that, it would look like this. It could be any number but not 4. So since it asks us to write it in interval notation, we're going to go from the left to the right side. So anything negative up to 4, not including 4. So the parentheses here mean that you can't plug in 4. If it was a bracket, it'd mean you could. Union, because there's a spot where there's no shading. And then anything greater than 4 can go in for the x spot. Okay, so if we look at number 8, it's asking us what number can we put in for x here? So what kind of numbers can we multiply by 8 and then add 24 to? So hopefully you're thinking any number can go in for x in that spot. So our domain is all real numbers. Okay, now if we take a look at our next example, we have a radical. So we know that we can't have negatives inside radicals. So we want to know what is the smallest number we can plug in before the negatives happen. So we want this whole thing to compute to be a number that's greater or equal to 0. So it's saying that 0 could be this number here or anything greater. So now we need to solve this. So we're going to add 20 to both sides. Remember, if we switch divide by a negative, we switch the sign, which we're not here. We're dividing by positive 4. So we get x has to be greater than or equal to 5. So if I graph that, greater than or equal to 5 looks like this. So interval notation would be 5, and anything greater than 5 can go in for x. Okay, so if we take a look at the square root of 4x minus 20, so if we take a look at that graph, it looks like this. So notice our answer was 5 and anything greater. So x can be 5 and then anything greater. So if I ask for a table here, so you could see when the numbers are not greater than 5, it says undefined. But if we plug in 5, we get an answer. Anything greater than 5, so for example, 7 has an answer. 100 has an answer. So x can be anything greater than 5. Now, if we take a look at number 10, it says y equals 3x squared plus 6. So it's asking us what number can we plug in and square it, multiply by 3, and then add 6 to. So hopefully you're thinking any number can be squared and multiplied by 3 and added to 6. So our domain would be all real numbers. So now if we check that with the graphing calculator, so let me get rid of this one. So that's the graph. Let me zoom in here. That's the graph for number 10. So you could see on the left it's going infinitely, and on the right it goes infinitely. It keeps going and going and going. So if we make a table, when you say that x can be any number, you could see that any number in this table has an answer. So even if we put in negative 800, it has an answer. None of these will say error, even if I put 20. Okay, so that's what all real numbers means. It means any number can go in the x spot and it has an output. All right, let's take a look at number 11. So we have a radical, so we say to ourselves, we can't have a negative inside the radical. So 6x minus 4 has to be a greater than number 0. So greater than or equal to 0. So then we'll add 4 to both sides. And then divide by 6. And 6 can't go evenly into 4, so we'll just simplify it to 2/3. So the number that goes in here for x has to be a number that is greater than or equal to 2/3. So a number greater than or equal to 2/3. So our final answer would look like this. So that means any number bigger than 2/3, for example, 1. So if I were to take this function and pick any number bigger than 2/3, so again, for example, 1, if I plug in 1, I would get 2. And the square root of 2 is not negative, so we're good. Has an answer. So that's what we're trying to find, the numbers that can go in for x. All right, last one here. So we have a fraction, and we know that the bottom of a fraction can never be 0. So we want to find out what number, if I plug it in here, will make this equal 0. So I'm going to solve this equation, divide by 6, and we get x equals, 6 can't go evenly into 3, so we just simplify it to negative 1/2. So x can be any number, but not negative 1/2. So if I draw a picture of that, it looks like this. Could be any number, but not that number. So it could be any negative number, but not negative 1/2, or any number greater than 1/2.